So now we will discuss about a few machine learning models that are available to solve the different types of problems, real-time problems. So first we will see what are the different types of machine learning models available to solve the regression problem. So in the previous session, we discussed about the comparison between the regression problem, binary classification, categorical classification, and the clustering problems. Okay, you identified which type of problem you are facing. You identified, based on our discussion, let's assume you identified which type of problem you are facing, for which type of problem you are trying to provide the solution. Once you identify the type of the problem, then you have to identify the models that can be useful to work on the problem. Once you identify the type of real-time problem, you have to identify what are the models are available to solve this problem. So for that one, I am explaining these things. So the machine learning model, to solve the regression problems, you can use linear regression model, you can use dense tree, you can use random forest, you can use support vector machines, and you can use the neural networks, and many are available, and few of them are listed here under the machine learning. Okay, so linear regression model, dense tree, random forest, support vector machine, and neural networks all can be useful to work on the regression problems. So in the previous session, we discussed about the difference, comparison between the regression problem, classification problem, and clustering problem. So these are the models available to attempt the regression problem or to solve the regression problem. Coming to the machine learning models for the classification. So machine learning models for the classification. So these are the few of the models. So you can see here, dense tree, random forest, support vector machine, neural networks, all can be useful for the, even KNN also, all can be useful for the regression problems. As well as these are useful for the classification problem also. Suppose if you are working on the classification problem, you can choose all these models or any of these models to find the solution, to build the application. So these are called as the classification based machine learning models, like a dense tree. Dense tree can be useful for the both regression and classification. Random forest, that also useful for the both regression and classification. Support vector machine also useful for the regression and classification problem. Neural networks also useful for the regression and classification problem. KNN also useful for the regression and classification problem. Where a naive-Bayes classifier and a logistic regression model are used for the only classification problems. Don't confuse, because it is a regression. So it is a logistic regression, but useful for the binary classification. So logistic regression model are used for the binary classification, and this the naive-Bayes classifier can also be used for the classification problems. Okay, so these are the few machine learning models that can be useful to solve the classification problems. Okay, I hope you understand what are the models are available to solve, and neural networks also useful for the both regression and classification. And the machine learning models which are used for the clustering problem. So you can use the neural networks to solve the clustering problem. You can use the K-means clustering algorithm to solve the clustering problem. And also you have the DB-scan clustering algorithm and optics algorithm. So there are the different machine learning algorithms are also available to work on the clustering problems. We are going to discuss about the not all machine learning models, at least one or two machine learning models under every category of problem we are trying to discuss. That means under regression we will work on one or two models, and under classification we will work on one or two models. Under clustering we will work on one or two models. That also we will see in the coming sessions. So I think as of now you are clear about how we can identify which type of problem you are working on, and also you are able to confident that which model are used for which type of problem. So neural network used for the which type of problems, naive-Bayes used for the which type of problems, logistic regression model used for the which type of problems. So you are clear with that aspect also. Okay, So of course, we are not discussing anything about the mathematics behind every model. That we will discuss after these basic concepts or introduction of all the things. Later only, maybe tomorrow after 15 minutes, sorry, today after 15 minutes or from tomorrow onwards, we are completely focusing on the mathematics and the implementation using the Python. Okay. Now, so what is the structure of the machine learning project? Suppose if you want to work on any project and if you want to work on any problem and you want to give some solution using machine learning or deep learning or AI, what are the steps we are going to follow? What are the steps we have to remember? So those things are listed here. The first foremost thing is you must understand the problem statement. You must understand the problem statement. Okay. So first thing is you must understand the problem statement. So let's assume. So first step is understanding of the problem statement. Let's assume. So step 1, understanding of problem statement. Understanding of problem statement. You have to understand the problem statement well. So what this understanding of problem statement? See, suppose if you are working for any software company or you are working for by yourself, you must get projects from clients, right? So you have to understand the problem statement means you have to understand the requirements of your client. You have to understand the requirement of your client. Okay. For example, let's assume, so I am a freelancer, let's assume, and I got a project from an electrical substation or electrical distribution company. Electrical distribution company, or you can call it TGNPDCL. Just example I'm saying. That is, I got a project from the TGNPDCL, that is Telangana Northern Power Distribution Company Limited. So this industry is my client. So this client will give the project, will give the problem statement. So that problem statement, first of all, I have to understand. I have to understand the problem statement first. That is very important. What client is expecting? What is your client requirement? That you have to understand very properly. Okay. For example, let us assume. So TGNPDCL, that client will give the project to me that. So build application, software application to forecast the load on various substations in Warangal. Let us do various substations in Warangal. Okay, so this is the problem statement. So first of all, you have to understand the problem statement. So what is the problem statement I received? So I have to build the an application to forecast or to predict or to estimate the load on the various substations in the Warangal. That is the problem statement. So I think you are, from this problem statement, I think you all are clear about my output variable or the variable which I am trying to predict. We all are clear. What is our output variable? My output variable is, my target variable is, the variable which I am trying to predict or forecast is load on a particular substation at a particular time. So that is my output variable. That means, so let us assume L of T, that means load on a substation at a particular time is my output variable or the target variable. Is my output variable or the target variable. So this is my output variable, or we can call it as a target variable. So I am clear. So from the problem statement, I understood that yes, okay, on the various substations, I have to forecast the load at a particular time. That's fine. So that is the variable identified. Now, what parameters we need to consider? What parameters we need to consider? That you have to think. Maybe your client will give the parameters. Maybe your client will give the parameters, or your client will not give the parameters. He will tell, so what things you want to do, what parameters you want to consider. You can consider. So that is none of my business. Finally, I want an application which is able to forecast, which is able to estimate the load accurately. That's only my requirement. So I am not restricting you to choose the which parameters you want to consider. Okay, I hope understand, right? Your client saying that. So let us assume I am going to my client. So, sir, I am clear with your problem statement. So I will build an application to forecast the load at a particular time in a particular substation. Please tell me, sir, which features I want to consider to estimate that load. So then he replied that, so that is your business, not mine. So you have to take what parameters are more appropriate. And you have to think my engineers. So you have to give the proper application which is able to estimate the load. Which features, which input parameters you want to consider, that is your choice. Like that he told. Then I discussed with some domain experts. Let's assume I'm a completely computer guy. I don't know about anything load related or substation related. Then I will go to the managers, or I will meet the engineers, or meet the various substation operators at the different substations. And finally, based on the knowledge what I gained, based on the inputs given by them, I identify the few features. Let's assume, just example I'm saying, let's assume. So I want to forecast the load at a particular time, L of t. So based on the last 3 hours load data, that means t minus 1 means 1 hour before, 2 hours before, 3 months before, and also last 3 days load data, t minus 24 1 day before, L of t minus 48 2 days before, L of t minus 72 3 days before. So just finally I choose total 6 input features to forecast the load on a substation at a particular time. So after understanding my problem, next step is what step I have followed next after understanding the problem. So let's identify what are the input features and what is the output feature or output variable. So as of now, this is my step 2. So maybe you can take another step 2. Step 2, nothing but you have to identify what parameters you can consider to estimate your output variable. That you have to think. If you have a domain knowledge, you can directly choose those input features of the variables. Or if you don't have any domain knowledge, then you can meet any domain expert and then choose your features which you want to consider. Right? Hope you understand. Okay? Fine. 1 minute, please. Done. Sorry. Fine. So that is the second step. After understanding your problem statement, next you need to identify what features you can consider to estimate some target variable or the output variable. So that is your second step, like this. So you may ask the question that, sir, why you consider these features? Do you think these features will give the better accuracy? No. So based on my discussion with the domain experts, based on my knowledge, let's assume I consider these. So if my model performance is not good, if the accuracy is not good, then I can try for some other approaches, some other features also. Just example, I'm saying all the things considering. So after that, what the next step? Now you identify the features, right? You identify the features. Now you have to collect the data. Fine. You have to collect the data. Okay. So otherwise, suppose some people are non-electrical graduates also there. Let us assume in our session, some non-electricals also there. So for that purpose, I am trying to take some other example. Maybe let us assume the project 1 or problem 1. So let us assume project 2. Here, so that hospital people gave the project to me. Let us assume some what's called some government hospital gave the project. That is build application to diagnose COVID. So you have to build the application to diagnose the COVID. Let us do. So then, after understanding your application, then what you have to do? You have to meet with the doctors. You have to meet with the different hospitals, and finally, you have to identify what are the proper, appropriate features or the parameters that should be considered to diagnose the COVID. So maybe like a fever and like a cold and like a cough and like O2 and like a pulse rate. So based on these features, I want to predict whether the person is either COVID positive or COVID negative. So like that, so in the second step, after understanding your problem statement, you have to identify your input feature, and also you have to identify your target variable or the output variable. So whatever project you are working, so you must clear with with respect to them. Once you identify your problem statement, after understanding your problem statement, after understanding your project statement, you can consider what are the features, input features you can consider, and what is the output variable you have to consider, that you have to separate, you have to identify properly. So once the features are identified, next step is go for the data collection. So you have to go for the data collection. Okay, you have to go for the data collection. So data collection means, suppose if you are working on the COVID application, then go to the hospitals and take the previous patient's data, both COVID positive, negative patient's data, and note down their fever, cold, cough, O2, PR, whether it's positive or negative. Like that, you have to prepare the data. Thousands of samples of data you have to prepare. You have to work with highly diversified, huge amount of data you have to consider if you want to build a more accurate machine learning model. You have to take the huge amount of data, thousands of samples of data, that also diversified data. So SAR told that 1,000 samples of data, I will collect that 100 samples of data and I will copy 1,000 times, so that I got that 1 lakh samples of data, so that I can train my machine learning model. No, don't make it duplicate. You have to keep the very diversified data, and also you have to use the large data. Don't use the duplicate data. There is no use. Okay, the size of the data should be more. At the same time, that may be a diversified data. Okay, don't copy. You don't collect the 100 samples of data and copy multiple times. No. Okay, so you have to collect the data from your organization for whom you are working. Whether you are working for the hospital, collect the data from the hospital. If you are working for the first problem statement, load prediction, then go for the substation and collect the data. Go for the substation and collect the data. So you can collect the data. So after collecting the data, you have to prepare like this. You have to prepare in the Excel format or any other format. You have to prepare the data like this, based on the data that you collected. See, in 2018, few of my students are working on the load forecasting problem, and they collected the data like this. So they collect the data like in a hard copy format, and they make it in a Excel, and later based on that Excel data, we worked on the load forecasting application. So I think you are clear with all the things. Problem statement understanding, identify the input and output features, and later you have to collect the data from the organization for whom you are working. Okay, more appropriate data based on your domain that you are choosing. So after that is called data collection. I think you are clear, right? So you have to collect the data. Make sure that your data is very large and also very diversified. So that thing you have to remember, and you have to spend as much time you want in the data collection and data pre-processing. No worry about it, because once you made a mistake in the data collection and data pre-processing, so everything will be gone vain. So everything will be waste. That's why you have to take more care in the data collection and the data pre-processing. Now after data collection, let's assume I collected the data from some substation in the hard copy. So I have prepared everything in the soft copy format like Excel sheet. So what the next step is, you have to work with the data pre-processing. So data collection, maybe sometimes it may be from the IoT devices also. Actually, we are working on the aquaculture project. So aquaculture project means we want to predict the quality of the water in fish ponds. We want to predict the quality of the water in the fish ponds. So based on using any deep learning models or machine learning models. So then what we did is we keep various type of sensors, like we have the pH sensor, we have the BOD sensor, we have the turbidity sensor, we have the temperature sensor. So by digging all the sensors in the ponds, and we are collecting the sensor data. So data collection no need to be manually. sometimes the data collection maybe should be done through the sensors also. Should be done through the sensors also. Okay. So let's assume you collect the data and you make it in the soft copy format. Once the data collection is completed, then you have to work with the data pre-processing. Third step, that means as per our discussion, it is the fourth step. As per the slide, it is the third step. So next step is okay, I missed a few things here. Next step is data pre-processing. So data pre-processing means, so majorly we are focusing on these four parts. One is called as a majorly. So I'm not saying that only these four. So many other data pre-processing also available. Majorly we are focusing on these things. So one is called as the missing value treatment. Second thing is called as the outlier treatment. And third one is called as the normalization. And fourth one is the data split. Fourth one is a data split. Okay. So what is the missing value treatment? So what the missing value treatment means? You can see. So let's assume you collected the data. You collected the data, thousands of samples of data from the various number of patients, right? So and you are entering the every value against the every feature. You are entering the every value against the every feature. Okay. Suppose it is a manual we are entering, right? Manually we are entering all the feature values, right? Maybe manually we are entering because of the human error. Maybe sometimes we missed a few cell data. Maybe I missed to enter the data in a particular cell in my Excel sheet in a data. So you can't train the model with this type of data. That is with empty cells. Your dataset contains the empty cells without any information. You can't use that data to train your machine learning models. It will not work well. Hope you understand, right? So these spots are called as the missing values. So because why it's called a missing value? In this cell, there is no values available. Because no value is available in a particular cell. That may be because of the human error, or that may be because of the sensor failures. At that particular amount of time, your sensor may not send the proper data. So because of that one, maybe at this point, the value is not available. That means at this point, your value is missing. So these are called as the missing values. So before training your machine learning model, after collecting your data, in between you have to work with the data pre-processing. So in the data pre-processing, the first step is the missing value treatment. So missing value treatment means in your data, against any input feature or the output feature, if any value is missing or not, you have to cross-check that one. So actually in the Python, we have the multiple libraries are available. You no need to check manually, because in the machine learning, we have to work with thousands of samples of data. It is very difficult where the values are missing. That's why in the programming, we have the libraries. You can use those libraries to identify the missing values. Right? So I think you are clear with the missing values. Missing values means in a data set at a particular location, if there is no data is available, that is called as the missing value. And the missing values are appeared in a data set because of the human error or because of the sensor failures. So you have to identify the such type of missing values before training your machine learning model. Okay. Next step is if that is the missing value is identified, if the missing point is missing location is identified, then you have to treatment have to be done. Only identification is no use. You have to do the treatment also, right? Suppose I have a fever. My doctor I have a thermometer and I kept my thermometer on my forehead and I identified that yes, I have a fever. That is sufficient. Identifying the fever is sufficient. We have to treat. We have to do the treatment also, right? Similarly, identifying the missing value is not only sufficient. We have to do the treatment also. Okay. How we treat the missing values? How we treat the missing values? So treating them, if you want to treat the missing values, there are different options are there. So different one is, if suppose this point is missing, this value is missing, then you can drop this complete row. You can remove this complete row. You can remove this complete row. You can remove if any missing value is available. That is one of the option to treat with the missing values. If you remove this complete row, then definitely this missing value is not available in your data set. If you remove the complete row, then that missing value is not available in the data set, right? So that is the one of the option. But actually, this is not a good choice. This is not a good choice. Suppose if you have the lakhs of samples, if you have the lakhs of samples or thousands of samples, if you have the 100 missing values, then you can remove the 100 missing rows, 100 rows corresponding to those missing values. That's fine. Hope you understand, right? So I suggested one of the treatment method, one approach for the treatment of the missing values is removal of the row. Removal of the row means if any cell, if any value is missing in the data set, then the row corresponding to the whole data, row corresponding to that missing value should be removed. The row corresponding to that missing value should be removed. Okay. This approach is easy and suggestible only if you have the large amount of data. Only if you have the large amount of data, then only you can remove the rows. If you have the less amount of data and because of this missing values, if you are removing every row, then if you are removing every row, then if there is no data available, how you will train the model, right? So that's why the removal of the row option will be suggestible if you have the huge amount of data. That means if you have the 1 lakh samples of data, out of 1 lakh samples of data, 100 missing values are there, 100 missing values are there, and I want to remove these 100 rows. That's fine. That's fine. Out of 1 lakh, you are removing the 100 rows only, 100 samples only. That is not a big issue. But if you have the only 200 samples, and out of which 100 are the null values, so that means missing values. And removal of the row concept, if you are removing the 100, you have the only 100 samples. With the 100 samples, what you will do? You can do, but you can't. You will not get a good model. Okay, that's why. So finally, my conclusion is, if you want to treat with the missing values, if you want to go for the removal of row concept, then that can be suggestible if you have the huge amount of data. Huge amount of data and less number of missing values. So that is the one of the method that will be used for the missing value rate. Okay, and some other methods also there. Other methods are like so see, as a data scientist or machine learning engineer, you have to apply your common sense also sometimes. Okay, you have to think accordingly. So I will tell why I am saying these statements. Okay, so one is the removal of row. That means you have to apply that common sense. So SAR told that removal of row. So I have the 150 samples. I have the 100 missing values. I will remove the 100 rows. So I have the 50 rows. I will use those 50 samples for the training. No, because the 50 samples what you will do, right? So that's why. So the missing value treatment using the removal of row concept can be applicable in case of huge amount of data. Suppose if you have the less amount of data, then how we will treat the missing values? So different ways are there actually. One way is what they will follow is, if this value is missing, right, then sometimes they will copy the previous value into this missing field. Sometimes they will copy the previous value into the missing field. So whatever the value is available here, same thing value will be keeping here. That is the one option. And sometimes the next value is replaced. We will replace this null value or missing cell with the next value. With the next value, we will replace. We will replace the previous value, or we will replace with the next value. I understand. Or sometimes it will be replaced with the average of the previous value and the next value. And sometimes it will be replaced with the mean value of the complete feature. In the feature, we have the 10,000 samples, let us assume. Out of 1,000 samples against that feature, what is the mean value? That mean value we will replace in this empty cells. We will replace in the empty cells. Mean value, median value, we will replace there. So there is a different types of approaches. But here I'm saying that here you have to apply the common sense. That's why I'm saying that you have to apply the common sense. Why I'm saying this this thing is, actually in the last year, maybe 22. In 2021 and 2022 academic year, and a few students are working on the load forecasting project. So they collected the data from one substation, at 3 by 11 kV substation. They collected the data, and they identify the input features, they identify the output feature, and they prepare the samples like this. For every day, they are prepared the samples like this. These are the different features. They develop the samples like this. Now, at some fields, they are observed that there is no information is available. There is no information is available. But if you have a contact with your domain expert, first you check with your domain expert from where you took the data. So the students also went to that substation and just they talked with the assistant engineer, and he told that at that hour load is not available because the substation is maintenance. Because substation maintenance, so that data is not available. That load data is not available. Okay, so let hope you understand, right? And this some Saturday particular about data, let it. And this is the Friday and this is the Sunday. This is the Sunday and this is the Friday. So we may go with the removal of row concept, but not suggestible. We can keep the mean value of the previous sample and next sample. One is the Friday and another is the Sunday. That is also not a correct option because one is the weekday and another is the weekend. So you can't take the mean value of both. That's not a good choice, right? So no one will tell us. We have to apply our common sense. Then what we followed is, in the Saturday data, this hour sample is not available. Then what we did is, 1 week back on the same Saturday at the same time, what is the data is available. After 1 week, that means next Saturday, what is the data is available. So we will take the average of these two and we will fill this missing part. So actually, no literature, no textbook will tell you. So these are the things only you have to apply. So that you have to think, and you have to discuss with your domain expert. You have to think, you have to apply your common sense and take action accordingly. Take the correct approach accordingly for the missing value treatment. That's why I'm saying. I hope you understand, right? So I think you're clear with what mean by the missing value and how we treat the missing values. I think you are clear with that one, right? So that is the one of the things, missing value treatment. Next one is called as the outlier treatment. Next one is called as the outlier treatment. Outlier treatment means actually data is available in the existing feature at every cell. Your data is available. In the missing value, data is not available. That is the missing value. But in the case of the outlier, data is available. In case of the outlier, data is available, but the thing is, the data is no more related to that feature, no more related to that feature. That may be because of the human error, or that may be because of the communication problems, sensor communication problems. So example, what I'm saying is, example, for example, we are working on the COVID prediction. Let us assume we are working on the COVID related thing. So the temperature is, they are kept temperature like that, 97.5, 98.6, 101, and again 987. So what is this 987? Actually, in this cell, the data is available, 987. That means there is not a missing problem. But here, this 987 is no more related to your feature favor. So this is called as your outlier. Outlier values are nothing but the abnormal values. The value is available against a feature, but it's not a normal value that appeared against that feature. This may be because of the communication problem, or maybe a human error. Maybe this temperature is a 98.7 Fahrenheit, but the person forgot to mention this dot. So it looks like a 987. So the outliers may be happening because of the human error, because of the communication problems of the sensors. So that type of outliers you need to identify. You need to identify outliers. Outliers is nothing but every feature have a different values. All the values are in some range. So if some value is beyond that range and very awkward, very abnormal when compared to the remaining all values, so that type of points are called as the outlier samples. Samples are called as the outlier samples. Okay, hope you understand outlier samples. So I think you are able to differentiate both outlier sample and also what's called missing values. Okay, in the missing values, the data is not available, but whereas in case of the outliers, data is available, but the data is not related much to the not related much to your feature. Not normal value to against your feature. Like this 987. 987 temperature will exist for any human body. That is outlier actually. So maybe that is happening because maybe it is a 98.7 Fahrenheit. While entering, they maybe forget to keep the dot here. That's why it looks like 987. So that is outlier. So generally, in Python or not in Python, based on statistics, outlier data is easily identified based on the Z-score method or box plot. Outlier methods are generally useful for the Z-score method or Z-score or box plot. Okay. So what is the Z-score? How we calculate the Z-score? How we find the box plot and how we identify the outliers based on this we will discuss now. Clear, right? Okay. Let's assume we have the feature x1, we have the feature x2, we have the feature x3, and we have the sample 1, we have the sample 2, we have the sample 3, and so on. We have the 1000 samples. Okay. So let's assume the x feature, y feature, this is the z feature. So we have the x1, x2, x3, so on, x1000 values. And we have the y1, y2, y3, so on, y1000 samples. And we have the z1, z2, z3, and so on, the z1000 samples. Hope you understand, right? Done. Done. Okay. Now what we have to do is we have to calculate the z-score value for every feature value. X feature, right? For X feature, we have the 1000 values, right? For every feature value, we have to calculate the Z-score. How we calculate the Z-score? So Z-score is calculated as Z-score equal to your value X value may be X1 or X value may be X2, X value will be X13, 1000 minus X minus mu. Mu means what is the average of all the values? What is the average of all the values? Mean value divided by 3. Okay, it's like a bell curve. Based on the bell curve, so minus 3 sigma to plus 3 sigma. If any data sample in this range, we can consider it as the normal value. Any value falling outside the band, that will be considered as a outlier value. If any sample is coming in between this band, then it will be the normal value. If any value is falling outside the band, that is called as the outlier value statistically. Method we are applying, that is Z-score. So how we calculate the Z-score? So Z-score is calculated as X means it may be X1 for this Z-score, it will be X2 for this Z-score, X equal to X3 for this value, and mu is nothing but the average of all the things by 3. So you can calculate the Z-score for every value in every feature. Similarly for the Y, similarly for the Z, everything we have to calculate Z-score. Understood? So after calculating the Z-score value, if your Z-score value is greater than 3, or if your Z-score value is less than minus 3, if it's less than minus 3 or greater than plus 3, then you consider it as an outlier. That you can consider it as an outlier. So whatever the values you have the Z-score more than 3 or less than minus 3, you can treat that value as an outlier value. You can treat that one as an outlier value. That's how we can identify the outlier values in a data set. Outlier values in a data set. If the Z-score is between plus 3 to minus 3, you can keep it as it is. But if Z-score value is more than 3 or less than minus 3, you can think it may be a outlier. It may be a outlier. I think you are clear with this one, right? Based on the bell curve. So how we treat with the outliers? Again, the same as the missing value treatment. Here also the same process. So one thing is, if your number of outliers are less and your data is very high, then you can go for the removal of row concept. You can go with the removal of the row concept. If that is not available, if the number of data samples are not large, then you go with either replace with the mean value, or replace with the previous value, or replace with the next value, or replace with the average of the both values. Like that you can do it. Okay, so that's how we can proceed with the outlier. Now maybe you can have a doubt. Actually, what I am suggesting here as outlier treatment is a statistical phenomena. It is a statistical phenomena. You no need to force it in the data pre-processing. So SAR told it is less than, greater than 3 minus less than 3. So you have to remove. So I will remove. No. So after identifying the Z scores, after calculating the Z score, after identifying the outlier values based on Z score, just check with your domain expert. My students also on that same project 21, 22, we calculate the Z scores. So based on the Z scores, we identified few values have the Z score value just minus 3 something, less than minus 3 like that we are getting. Less than minus 3 we are getting some Z score values, from some values. So because we have a mutual discussion with the domain expert, so we are not directly apply the outlier treatments. Directly we are not apply the outlier treatment like a removal of rows like that. But we again went to substation. Actually, that I'm giving some approximate values, but I'm not giving the fader details also because we can't disclose. So maybe it is a fader 1. That means one line from the substation going to the one particular area. The fader 2 going to the another area. Fader 3 going to another area. Fader 4 going to another area. On an average daily it is a 100 megawatt, 100 megawatt. So 100 megawatt, 100 megawatt. Let's assume. So total generally 400 around. Okay. But suddenly at some places we got the load of 200. Small value 200 or 180 or 150 we are seeing, because that one my Z score value is coming less than minus 3. So then we went again, we cross check with the data and we discussed with the engineer. They told that at that time you have the 150 megawatt of load because out of 4 faders, 2 faders are disconnected. There is some problem or some outages in the 2 faders. There is no power to these 2 areas. Out of 200, those areas are using only 150 megawatt. So that this is the value. They are. That's why you are getting the Z scores minus 3 like that he told. So we have to know. We have to know first why this was happening. So then we come back. We got the reason. We noted down everything. Then again we go with the same approach. So we identified which value observed as a outlier based on the Z score. That value is coming on which day, whether it is a weekend or weekday. Accordingly, we take the mean values. As I said in earlier missing value treatment, here also we applied same thing. So if it is a weekend value, identify the outlier, then the previous weekend, next weekend we consider and make it average and replace. So like that we change that data so that there is no removal of the data is available. Sorry, there is no outliers in the data, so that there is no outliers in the data. So that is how we can use the Z score to remove the outliers. But there is one more option is there to identify the Z score, that is called, sorry, to identify the outliers. There is another method is available that is called the box plot. So in the box plot, if you draw the box plot against every feature, then you can visualize few samples are falling above the maximum value or few samples are falling below the minimum value. Few samples may be follow above the maximum value or few samples will fall below the minimum value. So these things are maybe an outlier. So using the box plot, you can observe whether there is an outliers are there or not, but you can't know which value is falling outside, which value is coming inside. Below the lower value and above the upper value, which values are coming, you can't identify. So you can visualize the box from the box plot. You can visualize the outlier data samples only, but you can't know where that sample exists in the whole data. That's why my personal opinion is, instead of going for the box plot, you may go with the Z score method to identify the outliers in the data set. So box plot will give some visualization of the samples which are falling above the maximum value of the feature, below the minimum value of the feature, but you don't know where those are located. If you don't know where those are located, how we can treat with them? How we can treat with those outliers? That's the problem. So that's why I'm going for the Z-score method generally. So using Z-score, we can easily remove the values and we can identify the values where the Z-score is available. When we are going with the machine learning model labs, then I will show the code, how we can treat with the Z-scores, all the things. Okay. So this is the outlier treatment. So next one is the normalization. So normalization means, so that's also I will explain normalization. Let's assume we are working on the COVID prediction problem. So COVID prediction problem, features of the fever, oxygen value, cold, cough. So let's assume 4. Okay, here COVID positive or negative. So tell me the values are like maybe 98.6, O2 100, no cold, no cough, then no COVID. Just example I'm saying. So let's assume fever 103, oxygen level 80, cold S, cough S. So it may be a COVID positive. Maybe some other case 97.5, oxygen levels are 98, so no cold, but there is a cough. It may be a COVID negative. Understood, right? So some other samples you can consider like 98 and oxygen levels are 96, no cold, no cough, it may be 0 again. And again 106, oxygen levels are 90, cold S, cough S, it may be COVID positive. Like that you have the data samples. Now based on the fever, based on the O2, based on the cold, based on the cough, you are trying to forecast the code. You are going to diagnose the COVID, whether positive or negative. Okay, negative or positive, negative or positive. Fine. So the simple thing what I want to tell you here is, let's assume you are a student in a particular university or a particular institution. In that institution, so various students from the various parts of the country are coming to that institution and they will study. Generally, if from the student's perspective, student's point of view, if you want to do something for the student purpose, so students will come with the different proposals. Okay. So in that institution, local people are there who are the people from the local states, and few students, very few students are coming from the other states. Okay. So which students proposals will be generally I'm saying, which students proposals will be resolved very fast? Generally majority peoples are there, who are the peoples are there in the majority, so their proposals will be resolved very early, right? They will accept because of this majority, because of the huge amount, because of the high value, right? So what if there is a high value, they have the high value, they are high dominance, right? They have the high dominance. So they see, suppose during the elections also, in a particular area, if a particular caste peoples are more, then the political parties will give a seat to the person coming from the same community. And in a particular area, if a particular religion peoples are more, then the political party will give a ticket to the person who are coming from that religion party. Why? Because of the majority of the peoples are there. So here also, so here what I'm saying is, you can see based on these 4 values, I am trying to predict the COVID diagnosis, right? Out of these 4, COVID and cough values are between 0 and 1, whereas oxygen levels are up to 100, whereas fever is, oxygen and fever values are the around 100. These are the 0 and 1. So these are the very high values. These are the very high values. So sometimes there is a problem. That's why in the PPT also I told it is optional. No need to normalize every time. So you analyze your data and you can think later whether you have to normalize or not. So because of these high values, there may be a high dominance of a fever feature and O2 feature for diagnosis of the COVID by a machine learning model. So to avoid that dominancy, to avoid that domination, so what I want to do is, I want to normalize these values. I want to scale down these values between 0 to 1 like these two. Already 0 to 1, right? 0 and 1, right? So I want to scale down. I want to scale down these values also between the 0 to 1, so that all the data samples will be in the uniform range. So that is called as the normalization. How we do the normalization? So that is called, we are using the min max scalar method. Min max scalar method is there to normalize the data between the 0 to 1. Min max scalar method to normalize the data between the 0 to 1. So how we minimize that min max scalar? Suppose if you want to normalize this value, then what you will do? 98 points. So I will write the formula: x norm equal to x minus x minimum divided by x maximum minus x minimum. So x value means 98.6. So here you can keep the 98.6. X means out of all the samples, what is the minimum value you have to keep here? What is the minimum value? 97.5. So this is the 97.5. What is the maximum value? 106. Minus what is the minimum value? 97.5. Now, whatever the value you are getting, you can replace here. Suppose if 97.5 coming, so 97.5 you are writing here 97.5. 97.5 minus 97.5, 0. So this value becomes 0. If 106 is coming, then 106 minus 97.5 divided by 106 minus 97.5, so it is 1. So maximum value will be 1. If any value between the minimum value and maximum value, that value between the 0 to 1 value. Some value between the 0 to 1, maybe 0.4, it may be a 0.6, it may be a 0.5, like that example I am saying. Like that, every value, feature value can be normalized between the 0 to 1. Normalized between the 0 to 1. That is called as the normalization. So that is the option. You no need to do everything normalization. So based on your problem, based on your data distribution, you can recheck whether it is normalization is required or not. So that is the normalization part. I think you are clear with this normalization also. Okay, how we do the normalization? X norm equal to x minus x minimum divided by x max minus x minimum. Okay. Next. So after normalization, you are going to do the data split. You are going to do the data split. I want to write one thing. Okay. So after normalization, you go for the data split. So data split means, so you have the 5 samples of data, right? So generally, tell me. So I will explain about the data split, and we have the 33. Okay. Next 10 minutes I will explain about the data split, and remaining part we will discuss tomorrow. Generally, suppose if we are a teacher, if I'm a teacher. So generally what I am following, I teach one subject in classroom. I have the 5 units. Every unit, for every unit I have the 10 problems. So in the classroom, out of 10 problems, I will explain only 4 to 5 problems in the classroom. Remaining 5 to 6 problems I will not disclose. Same thing I will do for the remaining all the 5 units. Whereas in the second, in the examination, I will not give the problems what I discussed in the classroom. I will give the problem in the examinations which I kept aside. Right? That means, so whatever I am explaining in the classroom, that is like a training data. So during the training, during the explaining the subject, during the training, what data we are providing to the students is called as a training. Similarly for the machine learning also. Here students are learning, their machine will learn. So here for students, to make students to learn, we will give some information from the every unit. Few problems only we will discuss in the classroom. Problems what we discuss in the classroom are called as the training data. Similarly, machine learning model also, to train your machine learning model, out of 5 samples of data or 50,000 of samples of data, only few samples of data are used to train the model. So the data which is used to train the model is called as the training data. And the model which you used, which you separated, not discussed in the training, you separated, and which is used only for the testing purpose. So that data is called as the testing data. So what I mean to tell you is, so you have, you have the few samples of data like this. Right? So out of few samples of data, you can pick randomly few samples from your data and use those data for the training purpose. So the data which is used for the training purpose, that is called as the training data. And what are the data is remaining, that data is used for the test your model. This data will not used for the training, it is used to test the model. So if the model is learning, so I want to test the model whether it's able to predict properly or not. With which data you want to test the model, you have separated data, you have to keep the data separately for the testing purpose. That is called as the test data. That's it. So out of whole data set, you have to split few data. You have to split the data into the two parts. One is for the training and the other is for the testing. The splitting of the data samples can be done randomly. So don't think that first 10 samples I will use for the training and last 2 samples I will use for the testing. No, you have to randomly split the data. Randomly split the rows. Hope you understand, right? So that is the training data and another is the testing data. That's what we are following actually. See, if you train the students on the first 3 units and if you give the test on the last 2 units, it is a better option. If you train the students on the first 3 units and you test in the last 2 units, no, it's not better option. You have to train in all the 5 units and you have to give the different problems and for the training and for the testing. But the concept will be same. Okay, don't deviate from the concept. Concept will be same, but the you tell our student whether he is learning properly or not. If you give a problem that you discuss in the classroom, maybe he will give the proper answer, but not actual training, not actual assessment. You discuss the concept, you give some problems in the classroom, and you give some other new problems based on the same concept in the classroom, in the test. During the test also he performed well, then you can assess he is a good person, he is a well-knowledge person. You get knowledge, subject knowledge very well. Like that you can assess. You can give the A grade, B grade, whatever you want. But if you give the question which you discuss in the training, definitely he may perform well. Right? But that is not a case to assess the student capability, right? So that's fine. So what the finally coming to know here is, whatever the data set you prepared, whatever the data set you collected, you have to split the data set mainly into 2 blocks. One is for the training data and another is for the testing data. Make sure that you have the huge amount of training data. Testing data small also fine, but you must have the training data very large. So generally you may go for, you have the large data, then you may go for the 70:30. 70% of data for the training, 30% of data for the testing. But if your data is less, then it is better to go for the 90:5, 95:5. That means 95% of data you go for the training and only 5% of data you have to use for the testing. Right, understood it? So my suggestion, it is not a thumb rule. So you may, so 70:30 if you have the large data, 95:5, this is for the training, this is for the testing. So this can be used for the huge data is available. This data, this ratio can be used if the less amount of data is available. Like that you can split the data, one is for the training and the for the testing. And not only training and testing, sometimes we have the another set also that is called as a validation set. That is called as a validation set. So what is validation set? So you may have a doubt. Now we will going for our general human learning, not machine learning. For example, if we are a student of B.Tech, let us say, or as a teacher, what we will follow in the classroom generally, if we have the 5 units, every unit I have the 10 problems. That means unit 1 10, unit 2 10, unit 3 10, unit 4 10, unit 5 10. That is I will try like this. Then you can easily understand. So first unit I have the 10 questions, 10 problems. Second unit 10 problems. Third unit I have the 10 problems. Fourth unit I have the 10 problems. And also fifth unit I have the 10 problems. Then what I will do, out of 10, I will use 5 problems in the classroom discussion, 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 5 problems in the classroom discussion during the training. So this is called as your training data to train your student. Then out of remaining 5 more are available, right? 5 more questions are available, right? Out of 5 more, I will keep 2 problems and I will separate 3 problems like this. 2 problems as one bucket and the remaining 3 problems as another bucket. These 2 problems and these 3 problems. Like that, I want to split the data. Just for understanding purpose only, I am telling all things. Out of 10, 5 already used for the training. And remaining training, I split into 2 and 3. One is 2 problems in this bucket, 3 in this bucket. So what is this part is, so this is called as the validation data. Validation data. And this part is called as the testing data. So previously I told only training and testing, but generally we use the training data, we have the validation data, we have the test data. Now, what is this validation data? Now we will discuss. See, generally what we will follow in the schools or in the colleges, after 2 units completion, we will conduct the mid exam, right? So in this mid examinations, I will give these 2 to 4 problems. Why we conduct the mid exam in between? Because so I will test the students whether he is learning properly or not based on the questions which are not covered in the training. Based on the questions which are not covered in the training. Okay. So based on these questions, if he is performing well, then my training is good. In this mid examination with this validation data, if he is not performing well, then I think once. Maybe the problem with me or maybe problem with the student. If the problem with the student, then we will motivate them. If the problem with me, then my HOD will alter me with some other, substitute me with other faculty. So that thing validation is required because to check whether your training is going well or not. If your training is not going well, no need to wait at end of the semester. In between, you can take an action where you can stop the training and motivate the student or stop the training, replace the faculty. You can take some decision at the starting only, not at end of the semester. There is no use after end of the semester. What is the use of changing the faculty? Understand, right? So validation also same process. In the validation also, if you have a data, and huge amount of data used for the training, and some amount of data used for the validation, some amount of data used for the testing. So during the training only, these are all the 5 months training process. During the training only, I will give the test like a mid examination. So with this validation data, we will test the model. During this validation data, we will conduct the mid examination. So we will evaluate the student performance. Similarly, with this validation data, we will observe the training performance of a model during the training process only. If based on the validation data, if the error is very high and accuracy is very low, that means my training is not going well. Then I will kill the training process. I will stop the training process. Then I will change my data or I will change my model. I will take some action. I will not wait until 100 or 1000 iterations. In between, I will kill the session and I will change the parameters and I will restart the training. So that is the validation data purpose. So validation data will be used to test the model during the training process. So what is the purpose of test the model during the training process? The purpose is you no need to wait until training to observe the performance of your model. You set 1000 epochs, 1000 iterations model training. Don't wait 5 to 6 hours for the 1000 epochs running. In between, you can check the model performance with validation data. After 100 epochs or 150 epochs, your performance is not going well, you can stop the iteration and change the parameters, again retrain it. Don't wait until 1000 epochs. So that is the main advantage of the validation data. So once the training was completed, if the validation also good, training was completed, validations are good, then give the test data to check your performance of the model, whether you can go for the real-time deployment or not. Okay. So this is about the data splitting. You can split the data. Generally, if the huge amount of data is available, 70% can be used for the training, 15% for the validation, and 15% for the testing. If the less amount of data is available, you may go for the 95% for the training, 2.5% for the validation, 2.5% for the testing. Don't stick for these ratios. Just I am saying. What my mean is, my main goal is, if you have the huge amount of data, accordingly you have to change the proportion. Make sure that you have a huge amount of data is available for the training. You have the huge amount of data will be available for the training after data split. So accordingly you have to change the percentage. Okay, so that you have to remember. Fine. This is all about today's session. Tomorrow again we will meet